Okay, so in the previous classes we have studied regarding the formation of the different zones in the welding, fusion and heat affected zone, then the base metal zone, structure of the welds, and the heat affected zones parameters which has to be controlled, that are the thermal diffusivity, heat input and the welding speed regards. Okay. And also in the last previous class, the effects of carbon contents on the structure and the properties of the steel. Due to the carbon contents, what will be the changes occurs in the microstructure of the steel, as well as and the properties of the steel due to the carbon contents, whatever the changes may be occur, that we have studied. Then next, the shrinkage in the welding. Okay, what are the shrinkage in the welding, how does it occurs, and what are the parameters are to be kept in a controlled to avoid the shrinkage in the welding, or to reduce the percentage of the shrinkage in the welding. Okay, that you have studied. Then these are the some of the parameters with the diagram I have explained in the previous class. And also regarding to the residual stresses, the how the residual stresses are introduced in the welding processes in the workpieces after the welding. Okay, that I've explained in the previous class, and the effects of the residual stress is also explained. And next, some points we have discussed regarding the controlling of the residual stresses after the welding. Okay, and which are the methods for reducing the residual stresses, that also we have studied. Now next is an we have discussed in the next last class, that relieving the residual stresses, how to relieve the residual stresses after the welding is been done from the workpiece. Okay, there are two methods, are the penning and the heat treatments. So this also I have discussed in the previous class. If you are having any doubts regarding this all, so you can comments in your WhatsApp group, so I will make a video in the next class. Now today we'll go with the fresh topic, that is the concepts of an filler metal electrodes and the flux. Now there are three types of electrodes which are being normally used in the welding. So far up to all the four from the topic number 4 and topic number module number 4 and from the module number 5, so far you have studied, you have know what is an electrode, okay, and what is the filler metal. Now we'll study in lightly some details regarding that one. Okay, now you can see a filler metal is a metallic wire which is used to supply the additional material to and fill the gap between the two workpieces. When you are joining the two workpiece, there is a gap between the workpiece, that is nothing but the edge prepared of the workpiece to joint, okay, to different workpiece. That gap is been filled by the extra material, that is called as a filler material, which is of the same composite or the same alloy or the same material. Okay, if you are using the stainless steel two workpiece to joint, okay, the filler material will also be often stainless steel. If you are using a ms material, mild steel material, so the filler material will be of the same mild steel. Okay, not different material is not added as a filler material. Okay, because it doesn't fused with other material or mixed with other material, and you cannot adopt the property, it cannot adopt the property, and you cannot get the proper property of that weld material. Okay, after welding, for that reason the workpiece which you are going to joint, the same material, filler material, is been used. Okay, the filler metal is available in the form of rod and is made of the same material or nearby the same chemical composition as that of the base material. The filler material used in the arc welding processes is called electrode. So that filler material which is used in the arc welding is called as an electrode. Okay, so the filler metal is classified into three basic categories. Okay, three basic categories the filler metal is classified. So the first one is an coated electrode. Okay, then second one you can see over here, the plain, bare or uncoated electrode, plain or bare, okay, which is not coated with the filler metal. Coated means what? Flux has been coated. and third one is an fabricated tubular or cold electrodes. So we'll see the diagram and I will show you how does the electrodes are there. So see, in the, if you have seen the crackers or the what you can say, uh, Saurabh, 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 Guraj. Okay. So, oh, have you seen the electrodes during the welding? Can anybody reply me? Have you seen the electrodes during the welding? Have you all seen the electrode? Yes or no? No? You have not seen the electrode? Hello? Guraj? You have not seen the electrode? वेल्डिंग करताना बघितलायस की नाही रे इलेक्ट्रोड? हा सर कसं असतंय? हा जस्ट hello. Okay, leave it. Mute your mic. I will explain. So see, everybody have seen the agarbatti. You have seen the agarbatti. So see how it is. If you seen that agarbatti, there is a streak is there, wooden streak is there. For wooden streak, there is a coating is been given. The paste is been given, which is been dried. Then after it is been coated. Okay. The agarbatti you are using for the worship of the god in every temples everywhere, almost everyone's are using that one. Okay, when you sparkle it by the fire or you burn that one, afterwards what happened, the smoke is coming out. Okay, how the smoke is coming out? Because of the coated material, the smoke is coming out. It may be in an what you can say, in a what scented, just like an perfume smell. Sometime it's come. Okay, the different flavor what you can say, the different flavors smell are coming, just like an sandal, jasmines. Okay, different types of flavor, the smoke or the smell is coming when you put an agarbatti in your temple or anywhere. Okay, so same phenomena is occur in the electrode also. You can see over here there is a core metal. How does in agarbatti the wooden stick is there like this way, there is a core, one metal is there. For that metal the flux is been coated. Okay, the flux has been coated. The flux coating for this core metal, it may be the core metal is been dipped in a liquid flux, then afterwards it has been dried, then whatever the liquid flux is been sticked to this core metal, then afterwards it is dried. Okay, that liquid flux has been dried and the liquid flux is dried and it is used for the welding purpose. Now what do you mean by the flux? The flux is been used for making a gas. The flux has been coming out from making a gas and sheltering the arc. Okay, in the previous classes I have explained you in the arc welding, the flux coating is being done for the electrodes, which by the help of this metal the arc is generated. When it comes to the contact to the workpiece, the core metal comes to the contact to the workpiece, the arc is generated. Once the heat is generated, it starts to melt the flux which is coated on this metal. Okay, flux, when this flux starts to melt, what happens, it starts to release the smoke or the gas out. That gas sheltered or covered the arc over there. Okay, this is the important thing, keep in your mind. Then afterwards, due to the generation of an heat, okay, to an extreme level, this core metal also starts to melt. So these core metals work like an filler material in the both the workpiece. Okay, do you understood? So this core metal is work like a filler material in both the workpiece, and this flux is been used as an sheltering or removing the what you can say the gases. Now you can see the functions over here. At the bottom you can see the functions over here of the flux. To prevent the oxidization of the molten metal. Molten metal means what? Due to the heat, this core metal is been melt, as well as both the workpiece are been going to be melt. That going to fuse with each other. That molten metal oxidization. Oxidization means what? When it is in a liquid form or melting form, the atmospheric gases should not enter in that liquid. For that reason, the shelter is been prepared. Gas smoke is been prepared by this flux. Okay, help in removing the oxidization and undesirable substances present on the surface of the workpiece, and it also used for removing the undesirable surface from the workpiece, the flux. The chemical reaction with the oxidize and form and slag. The slag floats on the covers the top portion of the molten metal, and thereby preventing it from a rapid cooling. Okay, so see, one more important thing is that when this flux is melted, okay, and mixed with the molten metal, which are the metal going to melt over here? So see, the workpiece, both the edges of the workpiece and this filler metal, these three things are going to melt and mix with each other, as well as the flux. What does the flux do? The flux is also uh, melting over there, and but it makes like an slag means what? दुधावरती शाई असते की हाल काश्मल म्या केनी बर्तितला आथरा. Okay, the flux makes like an slag on the top of the molten metal. Okay, due to this slag, what happens? The at the bottom where the molten metal is there, it doesn't come with the contact with the atmosphere, outside environment. Okay, it's maintain its temperature and cools according to its temperature. Okay, it doesn't comes with the outside temperature because of the at the middle, or the slag is been covered at that liquid metal at the top. Okay, due to which the molten metal, okay, cool down slowly, okay, gradually, as per its own property or its own nature. Okay, when if there is a no slag, okay, it come to the contact with the environment or the outside temperature. So what happens? The molten metal will starts to cool rapidly. Once it's cooled rapidly, if it's cooled rapidly, apart from its natural cooling processes, what happens? Its property change. It will become an harder. For that reason, the slag plays a very important role to cool the molten metal by this manner. Okay, stabilize the arc. Stabilize the arc means what? It gives the shelter to the arc, okay, due to which the atmospheric contaminated or the atmospheric air pressure doesn't disturb the arcs during the burning. The arc at the initial, what it is having the burning flame, same burning flame is been controlled due to the flux. Okay, eliminate the weld metal porosity. Porosity means what? When the weld metal is in a liquid form, at that moment some of the gases may enter into the weld or the liquid metal, by which the porosity defect of the welding may be occurs. That to entrap all the going of and gases into the that liquid metal is been avoided by the sheltering of the gas. Okay, the gas shelter is been done. The minimum spatter adjustment to the weld. So the minimum spatter is been adjusted to the weld by the flux. So this is one of the these are the important functions of the flux. Now you can see over here the plane and the bearer electrode. Okay, so what do you mean by the plane and the bearer electrode? In this type, of the filler metal, the metal wire or the core wire is left plain or uncoated with the flux. So see over here, the flux is not coated for this types of plain or a barrier electrodes. It is just like an hollow tube or an hollow metal or a solid metal is there. Okay, it just like an filler metal. It just like an filler metal. These types of filler metals are being used for introducing the arc. Okay, once the arc is been introduced by due to the help of the external source of the gases are being reduced. Okay, though you have seen in the TIG, okay, the TIG there is a non-consumable electrodes is being used. So where the plain bearer types of sorry, in MIG non-consumable electrodes you have seen, where the plain type consumable electrodes you have seen. So these are the consumable. Okay, so in which the not the flux is being used for generation of the gas shelter. So the external inert gas are being used, just a tungsten or exxon gas are being introduced over there for making the gas shelters. Okay, for such types of welding processes plain and the bearer electrodes are being used. Now you can see over here tubular electrodes are there. Tubular electrodes, so the tubular electrodes are shown in figure. It is an hollow material containing flux constituency. So it is one of the hollow tube it is. Okay, but it is also having an flux. Okay, in the hollow tube, if okay, can you audio what happened? Can you hear me? Huh? It is audible now. Start kore. Guraj, Vishwanath, Vishwanath, can you hear? Vishwanath, okay. Just mute your mics. Okay, just mute your mics. Okay, when you require, then only open it. Okay, for the doubts, I will start. Okay, in the last class you have studied regarding the different types of zones. Okay, yesterday only I have started the new model, that is the soldering and brazing and metrological aspects in the welding. Okay, model number 5. In the last class we have discussed regarding different types of zone. That's are the fusion zone, heat affected zone. Okay, now structure of the weldings also has been discussed. Heat affected zones and its parameters also has been discussed. The thermal diffusivity and the heat input and the welding speed related is also been discussed in the last class. Now today we will start with the effects of carbon contents on the structure and the properties of steels. Okay, so see, each and every steels having the carbon content. Keep in your mind, each and every steel is having the carbon content, but only the percentage of the carbon contents is been varied. Okay, only the percentage of the carbon content is been varied in every steels. If the percentage is high, what will be the mechanical property of the carbon content? If the percentage is low, what will be the mechanical property of that steel. Okay, if the percentage of the carbon content is high in the steel, that steel will be an harder. The mechanical property of that steel will be an hardened and toughened. Okay, that mechanical property of the steel will be hardened and toughened. And with the the if the carbon content is less in the steel, that mechanical property of the steel will be ductile. Now let us see some points here. The steel is widely used in the material in the welding compared to the other material. Okay, the most probably the SS steel, stainless steel, and the high carbon steel, and MS mild steels are being used for the welding. Okay, these steels materials are been fabricated and joined in an assembly by the means of an welding processes. The steel may be defined as a refined pig iron, okay, or an alloy of an iron or an carbon. The various elements like sulfur, magnesium, phosphorus, etc. are being added to an steel in order to impart the properties like hardenability. Okay, so see, various elements like sulfur, magnesium, phosphorus, etc. are added in the steel. Okay, to impart the properties, so to increase the properties like hardenability means what? Hardness, strength, hardness, weldability means it can be easily welded, and the wear resistance, etc. So students, one more thing you have to keep in your mind: if the steel is having an high carbon, the percentage of the carbon in the steel are more than the welding capacity should increase. Welding capacity should increase in sense means what? The weldability is should require more. So see, the if the carbon is more in the steel, so the steel will be become more hard. If the steel is more hard, it's require high temperature to melt. Okay, so the welding arc which generates the heat, it's required a high temperature, so it is very difficult to weld the high carbon steel. If it is to be welded, it should be operated at a high temperature. Okay, keep in your mind. If the steel is having the low carbon, it should work at a low temperature, because it is having a ductile property, soft property, due to which the low temperature is required and the welding can be done in a low temperature. But the problem is that over here the heat affected area is increased in the ductile compared to the hardened one. Okay, high carbon steel. So compared to the low carbon steel, the heat affected area is less in the high carbon steel. Okay, this thing you have to keep in your mind, and these are the effects of the carbon contents on the structure and the mechanical properties of the steel. Now the shrinkage in the weld. What do you mean by the shrinkage in the weld? So you have studied in the casting the shrinkage. What is the shrinkage? So see, when any of the liquid material or the metal which is going under a high temperature, okay, or above the melting point, when it starts to solidify, when the temperature of that liquid metal is been reducing, at that moment what is happening? It is starts to solidify. When it starts to solidify, it changes shape. The shape of that liquid content what is there, or the liquid pool where the molten metal is there. Okay, the liquid pool surrounded that, when it start to convert into a solidified, its shape is been changed, or it is shrink means what? The dimension and the size has been changed. That is called as a shrinkage. This shrinkage is also happening. How the shrinkage is happening in the casting? Same way the shrinkage is happening in the welding also. During the welding, when the weld metal is deposited, the base metal means what? The workpiece is heated, thus is expand on the cooling. When it is cooling, it expand the base metal plus the weld metal. The base metal plus the welded metal, the metal which has been welded, is shrink. It observes that the shrink of the weld joint is far greater than the expansion. Okay, The shrinkage in turn to reduce the residual stresses and the distortion. Some of the residual stresses that you are going to study, and the distortion, what is the distortion, that is also I am going to discuss in this module in a deeper way. Okay. Now you can see the shrinkage in the welding and how to avoid the shrinkage in the welding. Do not over weld. Okay, do not over weld. Use intermediate welding. Use few weld pass as possible. Place the weld near the neutral axis. Balance the weld around the neutral axis. Balance the shrinkage force with opposite force. Now I will explain this each and every point, okay, by the diagram. You can see in this diagram. So see over here, if you want you can zoom it. In this first diagram over here, you can see overwelding. You can see over here there are the two diagrams. In this diagram a single welding is been done. Okay, if the workpiece is been welded at a first time, okay, at the first time, if you are joining a two material by depositing and welding material or the filler material, you should not overweld. Overweld means what? Once again you should not pass the electrode on that welding machine. Okay, you can see over here at the first they have done the weld, then once again on that only, once again on that weld material they have weld or deposited the welded material. So that thing is called over welding. Repeating the welding operation sequentially on the same place. Okay, deposition of the weld material on the same place one by one is called over welding. So this also make the shrinkage, okay, effect. Now intermediate welding. So this intermediate welding, what do you mean by the intermediate welding? So see, so this portion, this is an butt joint, this portion totally a welding pass is been going to, hello, just mute your mic. If you are any having doubt you can ask, otherwise mute the mic. Okay. So see, I will show with this one. So see, this is completely, it is going to be weld like this way. Okay, but before going to have a pass from this side to this side, okay, from here to here, to pass the electrode or the welding is to be done from this side to this side, or you can take from this side to this side. Okay, what they do, these two metals are to be joined over there. Okay, this one and this one is to be joint over there. For that what they do, the spot welding is to be done. Okay, they have done the spot welding and make that workpiece joint over there. Okay, make that workpiece to joint over there, so that complete deposition of the welding is avoided by having a 3-spot weld over there. Understood? Okay, by complete deposition of the welding, okay, by complete deposition of the welding, only the 3-spot welding is been done over there. Only on 3 spots they have given, in spite of doing a complete weld over there. Okay, now the minimum number of pass you can see over here. Same way the over welding. So see, once the electrode or the welding holder, if you are holding a holder with an electrodes, okay, if you placed on the workpiece, it should go in a single pass. Okay, then if it should be going in a single pass, if it is going in a single pass, the gradually or the equal temperature is been distributed, equal amount of the flux is been distributed, and equal amount of the electrodes are been distributed. Okay, so this is how you can avoid the workpiece to undergo any shrinkage effects. Now you can see over here there is a welding near the neutral axis. Okay, so see this neutral axis, what do you mean by the neutral axis? The axis which divides the load into an equal part. Okay, divides the load into an equal part. If you do the welding on the neutral axis, you can see over here, this is the neutral axis. Okay, if you do the welding by taking the help of that neutral axis of the workpiece, so the shrinkage, it doesn't allow the remaining workpiece to undergo the shrinkage. It can contract or it can hold the workpiece to its required dimension and shape. It doesn't allow the workpiece to change its shape by the shrinkage effect. Okay, this is also one of the important points during the welding is to be considered to avoiding the shrinkage. Now you can see over here the balance welding around the neutral axis. See, you can see over here there are the two diagrams they have given. This is a good welding and this is a poor welding. In this you can see the neutral axis is there. Above that neutral axis, above this neutral axis, the welding is done. That is an unbalanced. If you consider the neutral axis properly for the welding purpose, so it is called as an balanced neutral axis. Okay, so balanced neutral axis is can be get the good welding design. Okay, or good welding effects for the shrinkage effects. Okay, and this is an unbalanced because it is above the neutral axis or below the neutral axis, you can tell. So in the diagram they have shown above, or okay, or if you do the below, so it is a pure welding design. The welding design or the welding spot should be designed in such a way it should balance the neutral axis so that the shrinkage effects can be avoided or controllable. Now you can see this diagram over here. This is a metal sheet. Okay, at the bottom there is a wedge is there, or the wood wedge you can tell it, and over here there is a clamp, special design clamp is been made. Okay, in this clamp this sheet is been joined by the means of the bolts, nuts, or any of the clamping device. There are two sheets, one and this one is a second one. This is a one and this one is a second, one and two. These are the two sheets are there. These two sheets are being joined at the middle by means of welding. Okay, but after welding the sheet should adopt this shape, curved shape. It should adopt an curve shape, this type of curve shape. But when the welding gets solidified, cooled, the welding material get cooled. After the fusion, the welding deposit material starts to cool. Okay, then the welding materials get to convert the solidified after cooling. When it gets to solidified, obviously the solidification occurs, the shrinkage of that welding materials also occurs. When it undergoes for the shrinkage effect, so the shape of the sheets may change. The shape of that sheet may change. For that reason, to avoid the change of the shape, the clamping is been done over here. Okay, to avoid the shrinkage of that effect, that clamping has been done over here. Okay, so this is how the shrinkage effects during the welding can be avoided. Now removing the shrinkage force after welding. So see, there are the two methods. Have you seen the welding? After doing the welding, the welder is been doing a chipping on the weld metals. Okay, what is the chipping? Is that chipping is nothing but removing the carbon contents or the residual stresses. Okay, after doing the welding, so that type of chipping method is also called as an force, removing the force shrinkage by after after welding. Now you can see over here, the one method involves the penning and hammering. Hammering the weld with an blood records around the edges that will cause the weld bedded and stretch and make it thinner, thereby relieving the stresses induced by the shrinkage. But the panning may cause the damage for the weld material. Okay, because the heavy impact blow on the weld material may can damage the weld deposited on the workpiece and reduce it reduce its strength, and also it may change the properties of the weld material. So that thing you have to keep in your mind. Only when if you remove the residual stresses, then only the shrinkage effects can be controlled. For removing the residual stresses, panning or a hammering is being done. Minimize the welding time. It is a desire to finish the weld quickly before a larger volume of the surrounding metal heads up and expand. This helps to minimize the shrinkage effects. Okay, so this is also one of the important phenomena to control the shrinkage effects. It is desire to finish the weld quickly. As soon as possible, you start the weld and close the welding operation as soon as fast possible. Don't concentrate on a single point by the electrodes. If you concentrate, keep the electrodes or the arc at a single point, what will happen? That single particular point will melt more. If it melts more, the molten metal creation will be more. If the molten metal creation is even more, so the shrinkage effect will be more. For that reason, melt the metal less and join the metal more. What is the point? Melt the metal less and join the metal more. The metal, if you are going to join two metals, melt less metal by introducing in a lesser time the electrodes to that metal. Okay, within less time you have to melt the metal. If the less metal is melt, less heat affected area will be generated and less shrinkage effect will be generated. So that's why what they are telling, that minimize the welding time. If you minimize the welding time, within short time if you melt the metal, okay, the desire to finish the weld quickly before a larger volume of surrounded the metal heat up. Okay, within short time, if you take a less time to rewire melt the metal, so it will affect a less area and less metal will be melt. If the less metal is melting, it will go for the less shrinkage. Okay, so this is one of the important point that you have to keep in your consideration for melting, for avoiding the shrinkage effects. Now let us go for the residual stresses. What do you mean by the residual stresses? Now you can see over here, during the welding the thermal expands, during the welding the metal expands due to heat upon a cooling. Okay, the weld metal solidified and shrink. It solidified when it goes to for the solidification, shrinkage occurs, exerting stresses around on the surrounding the weld metal. In other words, the heating and the cooling of an weld metal is introduced. The residual stresses in the material, the residual stresses remains in the body material and independently of any applied load. So dear students, just listen that how the residual stress is generated in the welding and what are the residual stresses. Before going to the residual stresses, I would like to share one example with you all, how the residual stresses are introduced and what are the residual stresses. Just take one paper, okay, just take one paper and scrap it with your hand and hold it in your hand. Okay, then afterwards just release your hand. What will happen? The paper which you have scrapped in your hand starts to expand over there. Okay, when you release your hand power pressure, okay, it starts to expand over there. What is happening? The initially when you are scrapping that paper in your hand with a pressure, okay, you are applying a compression stress on that paper. Okay, once you hold in your hand that paper, scrapped paper, okay, the compression stress are been residual. Residuals means what? They are been inserted in that paper. Okay, residuals, the stresses are made in home to stay in that paper. Okay, once you release the pressure by removing your hand from that paper, okay, what happens? The stresses from that their home, which are made their home on in that paper, starts to come out. Okay, when the stresses come out, the paper starts to expand over there. So these types of stresses are called as an residual stresses. It may be the compression stresses, it may be the tensile, whatever the stresses which are been trapped or closed in that material, after some extent they come out. That types of stresses are called residual stresses. Okay, dear students, so during the welding also some of the stresses are been trapped in the workpiece material. Okay, then afterwards when the workpiece material has been when the welding process is been finished, then one by one the stresses are coming out of that workpiece material. Okay, now let us see what are the effects are been going to be done by that types of residual stresses. Now you can see over here the effects of residual stresses. The first point, the residual stresses can result in a visible distortion of an component. So what is the distortion? I will show you. So see over here, you can see this is a normal workpiece. Okay, normal workpiece during the welding. If the residual stresses are coming out in a maximum quantity, okay, if the shrinkage is not controlled, this normal workpiece can convert into a distort workpiece. Now you can see over here the distortion is being done. Okay, so see when if you burn the plastic, okay, if you burn the plastic and suddenly if you cool it, so what kind of shape you can see after burning? So the distortion is occur. You can see the distortion, the original shape of that plastic is being changed over there and it is compressed over there. That is called as a distortion. Why distortion? Then some residual stresses are there which are coming out and releasing continuously. Okay, so that is what the makes the workpiece to destroy distortion shape, or the shape is been changed over there. So this is how the distortion is occur. Okay, now second point, the residual stresses can reduce the strength of the base material. Okay, it is correct. When the more if there is a more residual stresses, obviously the property and the microstructure of the base material will also change and can lead the catastrophic failure through the cold crack. Catastrophic failure means what? The sudden and larger alteration sudden and larger alteration can be made in the microstructure of the workpiece, okay, through the cold crack. That is what the residual stresses can do, the major effect in the workpiece. Lowers the difficulties of the metal, lowers the ductility of the metal, lowers the ductility of the metal. So same, obviously if the residual stresses are more, it can change the mechanical property of the material. Okay, keep in your mind, the residual stresses may increase the rate of damage by fatigue and environmental degradation. What do you mean by the fatigue? If there is a residual stresses in the welding workpiece, but due to the help of the fatigue means what? Sudden impact. If you given a hammer blow on the workpiece, sudden impact, okay, suddenly if you give a hammer blow on the workpiece may crack, impact, that is called as a fatigue. Okay, environmental declarations means what? So see, if you are doing the wall, plaster wall, okay, construction building, or your wall is the construction of a brick, it is been plastered by the cement. The initially when you do the plaster on the first day, there you cannot find any cracks on the wall. How the days are coming out after curing means what? If you applying the water on that plaster wall, after few days you can see some cracks are been on that wall, as you can see usual the cracks some. Okay, visualize the cracks. Okay, what are that cracks? That cracks are nothing but the air or the atmosphere which is been trapped within that cement constructed wall after few days. Okay, due to the moisture content is been reduced in that one. Once you stop the water spraying on that wall, okay, the moisture content percentage is been reduced and that trapped air starts to come out by that wall. Okay, that trapped air is nothing but the residual trapped air. Like this way, in the workpiece also some of the residual stresses are been enclosed or been held in the workpiece, which comes out during the cooling or after cooling of an weld material and may crack out the well depositor. Okay, due to which if the crack is coming on the welded deposit material, if you give an hammer blow or a sudden blow, impact blow of any by using any tool, okay, that two weld joint which is okay, that two welded joint will be fatigue means what, get been cut or been go for the major crack on the from the weld deposit area. Okay, so this is what the residual stresses effects are there. Now how to control these residual stresses during the welding processes? The residual stresses are minimized by reducing the amount of the weld metal deposit. So see, so whatever the welded metal you are going to deposit to join two workpiece, that deposit material should be less. Okay, when this material will be less, just frequently I am telling that by reducing the welding time, just if you hold just simple thing, if you hold a candle, a burning candle at a one place, what will happen? So the candle starts to melt and it melt wax will be deposited over, will be fall in a drop wise. Okay, if you hold for a second or for a minute in a one position, so the whatever the molten wax has been coming on, melted wax will be coming out, that will deposit on a particular place in a larger number. Okay, so for that reason it should not deposit on a one place for a larger number. For that reason you have to move that candle, okay, from one place to other place by infrequent manner, so that the equal amount of the liquid wax can be spread over there or deposit over there. Same way in the welding also, the electrode should move frequently so that the equal amount of the temperature will be distributed for the both workpiece edges which are going to be joined, and equal amount of the weld is been deposited. Okay, so by which the residual stresses can be controlled and can be reduced. Since the residual stress results from the restrained expansion and contract occurs during the welding, the lower the weld metal deposited, lower will be induced stresses. The example use of an U grooves instead of V grooves consume the less weld metal. Now see, during the preparation of the edges, okay, in the last module I have explained regarding the edge preparation. During the preparation of the edge for the workpiece which you are going to be joined, okay, in that U shape and V shape, okay, instead of the U shape go for the V shape, because in the V shape the area of the edge will be less. Okay, in the U shape the area of the edges is been made more. Okay, if the thickness is less, so U shape is better. If the thickness is more, you go for the U shape. Okay, doesn't matter. If the thickness is less, so maximum possibility try the V shape, so that the area of the deposition of the welding material will be less over there. For that reason the residual stresses can also be controlled as the weld material deposition is been decreased over there. Okay, now let us see next point. Reduce the amount of the heat input to joint. Reduce the amount of the heat input joint. So see, the generation of an arc, okay, the transformer is there by which you can control the temperature, and okay, due to the controlling of the temperature the heat is can be obviously controlled. Okay, due to the transformer, that is an welding transformer is there which is used for making a circuit of an weld, due to which you can control the arc. If you are controlling the arc temperature, so the weld metal, so the timing of the metal to be melt and the fusion timing and the solidification timing, that is the cooling rate, can be also controlled. If you control the cooling rate of the weld material, okay, so that you can control the residual stresses also. Okay, the next third one, the welding sequence use should not be from one direct to other but rather in the segment. The welding sequence should not be from one directional to other. So see, if you are using an one directional from left to right, if you are going in same direction, the welding should be done. Okay, the electrode rod should be moved. The electrode rod should not move from then once again forward, right to left. If you are going left to right, same direction the electrode rod should be go. For the overpass, if you passing the electrode rod once again, so you should not pass the electrode rod from the right to left. Okay, just okay, right पासन left ला जर गेला, if you are going from the left in the right ಹೋಯ್ದ್ರ ಅಂದ್ರೆ right ಮತ್ತೆ ಪಾಸ್ ಹೊಡಿಬೇಕಾದ್ರೆ left in the right ಹೋಗ್ಬೇಕು. ಓಕೆ, ಉಲ್ಟಾ मत तरोदिल्ला, राईट ದಿಂದ लेफ्ट आणायचं नाही त्याला, राईट वरनं लेफ्टला आणायचं नाही, लेफ्ट टू राईटलाच घेऊन जायचं आणि लेफ्ट टू राईटलाच हे करायचं, एकाच डायरेक्शन मध्ये वेल्डिंग ठेवायची. ओके, सो दिस by this you can control the residual stresses generation in the workpiece. Okay, the residual relieving of the residual stresses. So see how to control, you have seen, and how to, what are the effect of the residual stresses. If the residual stresses are been trapped in the workpiece, okay, now how to remove that residual stresses, that you are going to study. The panning and the heat treatment. So the panning treatment is nothing but after doing the weld, okay, take one hammer, okay, by that hammer do the hammering on the weld metal with a blunt around edges, which causes the weld bed to stretch. Okay, put the hammer blow on the weld material, by which the weld material is being stretched. Where once the weld material start to stretch or the extend, okay, make it thinner. Okay, if the weld material is deposit in an thicker one, make it thinner by giving an impact blow of an hammer, so it starts to extend. When it starts to extend, the expansion of the weld material makes the residual stresses to flow through it. Okay, by like this way the residual stresses may come out due to an impact blow of an hammer and due to the expansion of the weld material. Now you can see the heat treatment. The heat treatment, for the example annealing, this is a thermal stresses relieving technique used that the employees control the heating of an weld material, usually in the furnace, and followed by the controlled cooling so as to relieve the stresses induced in the weld metal. The metal is cooled slowly either inside the furnace or in the atmospheric air up to the room temperature. So see, once the weld metal is been heated, okay, once the weld metal is been heated, once the welding is been done, then once again that welded material or the workpiece is been heated by the fire flame or the torch or in the furnace. Okay, once again it is been heated, then afterwards it is been allowed to cool in a rapid temperature. Rapid temperature means what? Fastly, by spraying in water, air, sprinkling the coolant on that one, so it can cool rapidly. When it's made rapid cooling, so rapid residual stresses are been entrapped or been removed out, or otherwise it can be exposed to the atmosphere for the open air, so it cools slowly and the residual stresses come out slowly by the room temperature. So this is are the two methods, panning and the heat treatments, are being used for relieving the residual stresses. Okay, so students, you can unmute your mics. If you are having any doubt, can ask. You are having any doubt so far? Pritam, ಏನು ಡೌಟ್ ಐತೆ? ಹಾಂ, ಐತೆ ದಿಗಂಬರ್, you are having any doubt? Guru, Guru Vishwanath. Huh? What? Are you understanding? Okay. Privately, no, sir. Digambar. Digambar. Hello. Hello. Huh? Any doubts, Digambar? Vishwanath. Vishwanath. Huh? No doubt. So see, this is a fifth model is very lengthy model. Huh? It takes a long time. ದೌಡ್ ಮುಗಿಯೋದಿಲ್ಲ ಇದು ಭಾಳ ಲೆಂದಿ ಐತಿ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಓಕೆ ಸೊ we'll okay so after the residual stresses still there are the concept regarding the filler metals. Okay, in the next class we will discuss regarding the what are the filler metals and the electrodes. Okay, and welding defects are there, brazing and soldering methods are there. So say those who are participate today, okay, Guru, Pritam, Vishwanath, Digambar, just write the comment on your subject groups regarding the today's class. If you understand, if you are not understand any topic, any problem is there. Okay. Just pass the comment on this one. Okay, just I will close the class today. Okay, go for the next class. Okay, just